Hello, everyone. Welcome to EECS 2011. It's a data structure course. I will speak more about the course content a little bit later. But I want to say Happy New Year to all of you. I think at this point, it's most important to stay healthy and safe. I hope everybody is doing that. Okay. I think today my intention really is to go over all the administrative issues, especially the course syllabus, to make sure everybody is clear about how we're going to proceed to actually complete the course in the following 13 weeks. And then I will do a little bit of motivating mini lecture, nothing technical, but just to motivate why we actually have this course for you in the second year. That's something I would like to do today. All right. Anyway, one thing at a time. First of all, I want to say one thing here. Okay. Maybe that's the biggest question you might have. So if you look at the registrar office entry for this course is supposed to be in person, right? Apparently, we are not running this course in person right now, right? So I haven't got any more information than you have. So at the moment, so if you got any question about lecture, and I'll definitely answer them. But I want to say one thing first. At the moment, according to the university, right? I think they sent a broadcast a message to everybody last week until January. I think starting from January 31st, tentatively, that's what the university said, that we will resume in person. That's according to the school. However, whether or not this is going to happen, we don't know, right? It really depends on maybe the government or depends on the school. So I cannot say anything. So please don't ask me this question. I just cannot answer. If I tell you any definite answer, it's only my guess, right? And I don't want to express my preference about either I want to go into in person or online, whichever way. I think that you will learn, hopefully you will learn equally well from me. Okay, anyway, that's something I want to emphasize first. I don't know whether after January 31st, whether we're going to go in person, online, I simply don't know. Okay, but for now, for the coming 2 to 3 weeks, we're going to run the course online. Okay. Let me now go over some issues with you, and then feel free to interrupt me. Feel free to open your mic and interrupt me. I don't mind, please. Or you can type your question on the chat. I'll try to monitor that every once in a while. All right. Just about myself, in case you didn't take any courses with me in the first year or your first half of the second year, I'm Jackie, right? That's the name I really prefer to be called. But if you want to call me Professor, Sir, Professor Jackie, that's okay. Doesn't matter. Okay, I'm quite informal person, so you don't really have to call me Professor. And I'm very keen to really look for feedback from students. So if you got any advice about how the course can be taught better, you can feel free to send me an email and let me know. Okay. And then there will be a bonus opportunity for you during the reading week, which I will invite everybody in the course to do some midterm course survey, just to tell me how you feel about the course and give me some comments. And then that's something I'll give you more details, right? That's about, throughout the course. If you want to suggest anything to me, just get in touch, right? Okay, so for those of you who are here today, if you're not officially enrolled in the course yet, maybe you intend to join the course, or maybe you are now in the waiting list, so please make sure you send me an email as soon as possible, okay? You will see my email in a moment on the syllabus. Send me your name, your student number, your passport, your ID, so I will be able to add you to the e-class, so you can get access to some other stuff for the course material. Okay, but of course you'll be expected to really keep up with the study materials even before you got officially enrolled. All right. Okay, and then okay, so let's see this. Okay, any assignments and tests which I will announce in a moment. There will be no extension for those of you who are not officially enrolled. So you might want to make sure you keep up with the work. A very quick message over here. I am very informal, and so when you write me an email, as long as you give me some courtesy, it will be acceptable. So yeah, I just give you some example over here. So try to avoid writing me to me in a very rude manner, which I wouldn't really appreciate. Okay, that's something I want to emphasize on day one. Okay. Otherwise, I think usually when you send me email, I try to be as responsive as possible. If I'm besides the computer, if I saw you sending me inquiries, if that can be responded right away, I'll do so. All right. Yeah, but just please keep the tone friendly. I'll be very grateful. All right, just about the course information. Okay. So there is only a single e-class site. Well, let me show to you. I'm pretty sure many of you already have received the announcement from me last Friday. So this is the e-class. Of course, if you haven't got any access to it, you can send me an email. I'll give you access. At the moment, we haven't got many things over there. We only got the course announcement. I would suggest if you haven't got, usually you should be notified by email when I send out the announcement. So make sure you check your email regularly. If there's anything that's important, you don't want to miss it. And also, there is a link over here about the study materials, okay, which I'm going to click on that. If you click on that one is going to link you to this particular site. This site is public domain. You don't need to get enrolled into the course. For those of you who know me, I posted all my study materials in the public, especially for the lecture recordings. I posted on my YouTube channel. So you can definitely refer to them anytime you like. Right? I think that will give you some flexibility in learning. But I'll go over the sites in a moment, okay, to give you more idea how to navigate. I think this will be the sites that you will actually be navigating the most throughout the semester. You will only get to the, typically you will only get to the e-class when you have to maybe download maybe assignment instructions or you have to take some tests. I'll talk about them in a moment, okay? But that's the e-class site. And also the lectures page over here. I also gave you the link in the e-class announcement earlier, so you can definitely refer to it, okay? I'll go over the structure with you on the site a little bit later, okay? And for the e-class site, usually you can find announcement. I'm teaching both sections N and Z. So these two sections will be taught consistently. So whenever I make announcement from the e-class, it's almost always meant for both sections. If that's an announcement only meant for section N or Z, I will tell you explicitly, but you can assume it's usually for both sections. And we will have assignments, but I'll talk about it, but assignment instruction will be available on the e-class, right? So that means you got to log in before you can get access to the assignments. And there will be programming tests. I'll speak about it. And also there will be written tests, and both of them will be done on e-class, right? But before each one of them, I'll give you some idea about what the coverage is and also what the format is. For that one, you don't need to worry. I'll give you at least usually about 7 to 10 days to get prepared. Okay, but as long as you follow along the study materials, it should be okay, right? And then there will be an exam as well. Of course, in case we really return to in-person learning, so there is a possibility that we may have to take the exam in person, but we don't know yet. For now, I may assume that's going to be online. Okay, just for now. All right, and check your email regularly, please. And the required study material will be the site I just mentioned to you over here. Let me just go back to the site over here. And so these are the Zoom links that you will see, right? For now, I simply put a Q&A just for this week. But later on, I'm going to change it to the weekly Q&A, which I'll explain a little bit later. Okay. And also the first one is a Zoom link for my office hour. So I'm going to announce them as well. Okay, so I got some background over here. It's not required, but it will be recommended for you to actually put your programming assignments into a private GitHub repository. So later on, once the course is finished, you can feel free to make it public to show off what you have done in the course. But during the course, it must be private. Okay, and this course actually definitely got a prerequisite EECS2011, which I'm pretty sure all of you have already completed. So that means I'm going to assume everybody is proficient in Java programming. For those of you who might feel not so confident about Java OOP in Java, in which case I will recommend you actually go to this link over here. You can simply go there. That's the complete resources I made available in the past fall, about lecture recordings, about slides, and also all the notes over there. You can definitely refer to it if you want to. If you're not too sure about which part you should really look at, you can feel free to drop by my office hour. I will guide it. I will walk you through with it. Okay, but it's optional, only if you feel the need. And then this section over here is for today. So now you can see we got the course syllabus over there already. You can click on that now, and that we're going to go over that together. Okay, and also we're going to have the recording for today and also tomorrow for the Q&A. It's going to be similar, the two Q&A about the same syllabus. We got some slides, which I'm going to present today, and also the weekly schedule and also semester calendar. That's something I'll also go over with you. And at the moment, the weekly lecture recordings has not been posted yet. All the lectures all the lecture content will be asynchronous, meaning that I'm gonna release the lecture recordings on a particular day every week, typically Wednesday. Okay, so that means in about 2 days you will receive the links to the lecture recordings. You got roughly about a week to study them, and then you can drop by the optional Q&A section to ask me questions. I'll give you the precise schedule in just a moment. But later on, you're gonna change. You're gonna check. Wait for my announcement. Once the lecture recordings are ready by Wednesday, you can actually refresh the page, and then you will see all the links over here. Right at the moment, it's not there. Okay. All right, and then the course syllabus. Okay, before I go on to talk about the course syllabus, are there any questions about what I have said so far? Before I move on, anybody? How do I get my passport York ID? That should be associated with your York ID, right? Not a student ID. Your student ID is the numerical digits. It should be your email should be something at myyork.yorku.ca, something like that, right? Yeah, exactly. Yeah, that should be associated with your email. You should have one. And for office hour, you don't need to book appointments. I'm gonna announce exactly the hours. Just drop by, okay? And okay, let me see if there's anything. So there are no live lectures. That's correct. So all the lecture recordings will be made available on a weekly basis. So that will give you the flexibility to watch them all. Watch about 3 hours every week to actually watch. You can maybe distribute the 3 hours over the 7 days before the Q&A session occur. Okay. All right, let me move on to course syllabus. Okay, as I said, you can go back to the lectures page and download the course syllabus. You can click on that, and this is the document which I'm going to go over together with you. Okay, let me now switch to the course syllabus, which is this PDF over here. Okay, yeah, I think there are certain to really save everybody's time. So I'm gonna just go over parts which might need some explanation. For other parts which are more like a policy, I can just let you read it. Right? It's rather straightforward, so we don't need to waste your time today. Okay. All right. About the okay, page number, this page here. About the course policy here, I'll let you read it. There's something about plagiarism, something about online submission, and also something about no teamwork. Basically, for all the programming assignments, all the tests, either programming tests or written tests, and the exam, all of them will be individual work. So please make sure there should be no collaboration in any way, shape, or form. All right. And then for those of you who actually haven't enrolled yet, please send me an email as soon as you can. So I will give you access to the e-class. All right. So I'm going to assume that everybody is going to read the course policy to make sure you get yourself familiar. Okay. All right. And then similar for this part here, about your I think most of the assignments will be programming based, mostly. Okay. Mostly just about Java programming. So make sure you actually complete it individually, and also to avoid these parts over here. Usually for my courses, I actually ask the TA to do plagiarism check after the submission. So I will make sure that there's no collaboration. If there's any suspicious submission that's submitted, we'll actually report to Lausanne. So please take it seriously. Okay, but you're more than welcome to ask me for help before the assignment due dates. And then I'll try to maybe arrange some TA office hour. Oh, by the way, for this course, 2011, if you notice that compared with your 2030, in this course, there's no scheduled lab, right? There's only lecture hours. But I'll try to maybe schedule some TA, like a TA office hour. If you want to speak to them about lectures, about assignment, I will definitely do that. So give me some time to arrange them, to coordinate with the TA. And for your best advantage, I will try to do some survey online to see which times you might prefer the most for the TA office hour. Okay, I will get in touch with you about this. So hopefully that can start happening maybe next week or the third week, the latest. Okay. All right, so guys, this part here, I'm not gonna waste your time by going over the details. So please read them. But just about academic integrity, I take it very seriously. So please do your own work. All right, don't take chances. Okay, so about instructor. Oh, about office hour, right? I haven't spoken about it. Okay, so the scheduled office hour by myself is going to be 2 to 3 p.m. Eastern time, and then Monday, Tuesday, and Thursday. So starting from tomorrow, Tuesday, you can already find me in the office hour. How can you find the Zoom link? Let me show you again. If you go back to the lectures page and then go to over here, and on the top, you will see the Zoom office hour. If you click on that, you can link to my Zoom room. And typically, you can expect maybe some queue. So that means you gotta wait. But eventually, I'll get to you. Don't worry. Okay. All right, that's about the office hour. It's gonna be 2 to 3 p.m. EST, Eastern Time, and also Monday, Tuesday, and Thursday. If it really doesn't work for you, or sometimes you want to see me urgently, maybe for other matters, you can definitely make an appointment with me. Just send me an email, and then we'll try to work out something that will work for both of us. And I talk about the e-class site, okay? And for the study materials, there will be no textbook for this course. All you got to do is to study my slides and study my lecture recordings and study any example problems which I'm going to bring to your Q&A section, or maybe some example questions. I'll talk about the Q&A a little bit more. Okay, so that's the web page, and this part over here is really about, since we are assuming that in this course that you are proficient in Java programming. So for those of you who actually are not so confident, I would suggest start with this particular link which I just showed to you, right, about just going over some relevant topics in 2030. If you got any concern about your Java background, I would suggest maybe also speak to me as soon as possible during my office hour. Right? For those of you who really are very keen to read, no problem. So these are the two books which I really recommend. So one is about data structures and algorithms in Java. Okay, and also the other one is algorithms, either one. And the second one is actually very exciting, because that one there, the authors also got recordings for their lectures, right? So, but of course, their way of teaching may be different from mine. So you can feel free to really do that as an extra study if you wish. Otherwise, studying my materials should be enough for this course. Okay. So that's about study materials. And then office hour, TA office hour, and also the weekly Q&A. I'll talk about the weekly Q&A section in a moment. Okay, so but these will be the available help resources to you. Okay, and that's about a prerequisite. I'm pretty sure you have satisfied that. Otherwise, you would have been de-enrolled already. So I'm not going to worry about it. All right, course description and also course learning outcomes. Basically, for every lecture every week. In the beginning of the lecture, I will always talk about what will be the learning outcomes for that particular lecture. So I would say we only get to the learning outcomes when we study that particular lecture. So going over this right now may not be so wise, right? Because you still cannot really appreciate what's going to be taught. So I would say we skip this part just for now. But as we go for the weekly module that I record, I will definitely mention what will be the learning outcomes that we're going to achieve for that particular week. Okay. But feel free to actually read through the course description and also course learning outcomes, right? All right, what about the grading scheme? Okay, so, sorry, let me just come back here. Okay, so there is no weekly lab since there's no scheduled lab. So what's going to happen is we're going to get 3 mostly programming assignments, 5% each. Okay, and also we'll get 2 programming tests, and also 10% each. I'll give you example test before at least 1 week before the actual test, so you can definitely get used to the formats. The programming test, I can tell you that it's going to involve implements, classes, and also methods in Java. And then it's going to be graded by JUnit tests, which I presume you already learned about in 2030. So if you got any trouble or in your background knowledge about implementation in Java, please get in touch with me as soon as possible. I'll point to you the resources. Okay. And we also got 2 written tests, and they will be mostly multiple choice. Right? There might be some written part as well, but they will be it will take place in E-class. Okay. And 10% each, okay? And then we got the exam, which will be everything accumulative. That will be 45%, right? So that's the breakdown for the semester, right? So that's just a table. I'm going to show you the semester calendar. You will see we actually try to spread out the evaluation throughout the weeks. So you actually make every 2 to 3 weeks, you got some evaluation or assignment to do. I think that would be nice for your learning, just to keep pushing you. Okay, not as intense as the 2030, but hopefully that's still good enough for you to push you to work hard. Okay. All right, for section N and section Z, it will be, as I said before, it's gonna be they are going to be taught consistently. So all the assignments, all the written tests, all the exam and programming test will be the same. So the main point I want to make is there's no fairness issue. So you will be taught fairly. I'm not going to give any advantage to section N as opposed to section Z. Not the case. You will be evaluated by the same scheme. All right. What about the expected weekly workload? Okay, I can only say on average. Okay, according to Lassonde. According to Lassonde, every credits is going to require 3 to 4.5 hours of work, including all the lecture. Okay, so for this course, since it's 3 credits, it's going to be between 9 to 13.5 hours per week. Okay, that's a rough calculation. And I would say at least you want to make sure you study the lecture videos. I'll make sure it's about 3 hours. Sometimes less, sometimes maybe slightly more, but it's about 3 hours of lecture video. That's why I thought the best way is to release it on a particular day and then give you 1 week to really plan your time to steadily study that. That might be the best. Okay. And what's really optional there is about the Q&A. I'll get to it. Don't worry. And also the office hour. So these are optional. I'm always happy to speak to you if you want to talk about the course contents or any concern you have. But try to speak to me as early as possible, right? So I can still make a change for you. All right. And outside the class, you have to make sure you spend the time completing the programming assignments and also study for lectures and also tests, right? Of course, the 3 hours of lecture doesn't really mean after you're watching all the 3 hours that's you're done. Not necessarily. You may still have to maybe reflect and also think about the issues and maybe even join a Q&A to ask me questions or maybe reach out to me during the office hour, right? So it's not necessarily just 3, okay? And I want to say that this course is a very foundational course, 2011, and some of my colleagues like to call this the interview training course, okay? Interview training course. In the sense that many of you may apply for co-op or internship later at some points, in which case you will be interviewed by some technical staff in some company, and they will give you the so-called programming interviews. So how can you get prepared? You have to know the common data structure like a linked list, array, heap, trees, and graphs. So these are all the topics that we'll cover in this course. So that's why it's a very important course. So I would say don't really feel bad if you have to spend beyond the recommended hours. I think that it will definitely pay off for your future career, right? That's something I want to mention. Of course, if you found that you definitely spend excessive number of hours, in that case, there might be something that can be improved in terms of your study method. In that case, get in touch with me. I can give you some advice, all right? Guys, any questions so far, please? Anyone? Just for the Q&A, I can see one question from Yan. So there will be 2 Q&A sections, which I'll show you the schedule. You can join either or both of them. Just I don't really check enrollments in the Q&A, so you can join any one of them. All right. Okay, hearing no question here, let me go on.
Yeah, Professor, sorry, I do have a question.
Yes.
I was wondering, what date do they check enrollment to bump you from the course?
What date do they check enrollment for what? Sorry.
For prereqs.
Oh, prerequisite. I believe they already checked it for once. Maybe around the 30th of December last year. I believe they did it already. I believe they might do it again, so that they can clear the space, maybe for people on the waiting list. So, okay, I see something about 16th of January. I'm not too sure. So if you're worried about whether that you may not have satisfied the prerequisite, I would suggest you get in touch with the undergrad office. You know their email? I'll already email over here. It's a UG at EECS. Okay, EECS.yorku.ca. In case you don't hear any useful response, get back to me, I can give you the email of our science vice chair. But maybe I wouldn't give his email right now over here. Okay. Oh, good. Okay.
Yeah, you are. Thanks.
Okay, very good.
I emailed. Thank you, Professor Jackie. Bye.
Okay, guys, any other questions? Okay. Yeah, I can see something about like an exam being 45% exam. I think the exam, first of all, the nature of that is going to be quite different from like a single written test, because for every single written test, we only focus on the only maybe 2 or 3 particular data structure, so you know precisely how to precisely what to cover. But in the case of the exam, it's really to see how well you can put everything together into a single assessment. I think that's why the exam is actually much more than the others. So I think the grading scheme might stick to the same, being 45%. But I would say study materials, throughout the course. Whenever you got any thing to clarify, get in touch with me. I think that'll be your best bet to take the exam. Yeah. Okay, another question here, which is a good one, from Liang. So if this course became in person, hypothetically, will the lecture still be uploaded to YouTube? Yes, I think I will be required by the school, which I'm quite willing to do that too. So I think in case we have to return back to in-person learning, then our weekly schedule might change a bit. But I would say let's not go there. If that really has to be the case, I'll get in touch with you. For now, you can always assume you always got lectures available either in person or remote. Okay. All right. Good. Okay. Good. Let me move on. Okay. But guys, anytime if you want to ask questions. All right. This is just about your grade calculation. Okay, what's going to happen is eventually we're going to calculate the roll marks. That might be quite standard for your other courses as well, right? So I would say you can go over that yourself. The roll mark is going to be something out of 100. And then, for example, if you got maybe 75, that one is going to be mapped to a B+. If you got maybe 70, if you got 89, of course, that's going to be mapped to maybe A, something like that, right? Very standard calculation. There's no trick over here. I think you can just look at the example over here to go over. If you got any doubts about it, you can reach out to me, right? So I don't need to waste your time, okay? All right, another one. Okay, semester calendar. Let's now go over that, okay? Now, what I would suggest you do, if you can please go back to the lectures page over here. All right. If you see this part over here, there is a document here called semester calendar over here. Let's now go over this together. Okay. That one will actually outlines exactly what's going to happen during the semester. Okay. Overall, let's see. The lecture is going to be released on Wednesday. Okay. So that's why you see on the 12th, this Wednesday, we're going to release week number 1 lecture. So week 1, week 2, week 3, all the way to week 12, always on Wednesday. And then, if I can release earlier, I'll try to do that. Okay. And then there will be a Q&A section for the lectures. I'll speak a little bit more about it once I see the schedule for the week. But you can just remember the Q&A is going to happen on Wednesday and Thursday. For this week, there will be no Q&A just for this week. You can see there's nothing here for this week. The Q&A for lecture will only start to occur from next Wednesday and Thursday. Okay, only next week. So today, Monday, this week, Monday and Tuesday are simply just special sections to go over the syllabus. There will be 3 assignments, 1, 2, and 3 over here, right? And also there will be a written test. You can think about this written test over here because at the time we actually have the written test, we would have already finished the Q&A for week number 4. So that means it's going to naturally cover all the contents for week number 1, 2, 3, 4 for the lecture, right? That's how you read the calendar. Similarly, if you look at written test number 2 over here, when you are at this point, we would have already finished the Q&A for week number 8. So that means it should really cover maybe from where we ended with 5, 6, 7, 8, right? That's how you read it. But before the test, at least a week, I will tell you the exact coverage that you should study. So you definitely got enough time to get prepared. There will be 2 programming tests over here. I haven't decided exactly what the topics might be. For example, it could be that in the programming test 1, I'm going to focus on linked list. Maybe on programming test 2, I'm going to focus on trees. But I'll definitely give you the precise guidance about how to study them. Okay, written test and also programming test. And you got your study date on April 11th in 13 weeks, and then this will be the exam period. So the exam date and also time are going to be determined by the registrar office. As soon as I know about it, I'll confirm with you. Okay, but we know that it's going to happen between April 12th and April 29th. So officially speaking, try not to commit to something so that you will not be able to take the exam when it's actually confirmed for the dates. Okay. Yeah, for the first 3 weeks. Yeah, I saw the question on the chat. Let me answer that, and I'll take your question. Nothing due on the first three weeks. You're right. Nothing. However, I would say try to make sure you study the lecture properly, and then as we go on to this part over here, we'll see you got assignments, you got written tests, you got programming testing, etc. I want to make sure I teach enough so that I can assess you. Okay, that's one of the questions on the chat.
Hi, Professor.
Please go ahead.
So when are we expected to study for the specific week? For example, it says that on the 9th of February, book 5 is released, and there's a written test 1 about 4 days after that. So are we expected to study week 5 for written test 1?
Good question.
For example?
Let me sure. It's a good question. If you talk about written test number 1 over here, okay, you can see at this point we would have already finished the Q&A. I assume that after the Q&A, you would have already clarified most of the doubts. That means written test 1 is going to cover week number 4, week number 3, 2, and 1. And as for week number 5, which was just released, I wouldn't expect you to really know the contents very well. I think it's a fair game. Is that clear to you?
Yes. Thank you, Professor.
Awesome. Good. All right. Let's see. Okay. Let's see. Okay. Good. I can see some good words about my teaching. Thank you. That's fine. Thank you so much. Okay. What would be the formats for the assignments? Okay. Yeah. Since I cannot assume everybody actually took 2030 or 1022 with me, so for the assignments, guys, don't worry. I think I'm still trying to organize some stuff. I'll try to, for the assignment number 1, 1, 2, and 3 are going to have consistent formats. So it's going to be mainly programming assignments. And I would say, maybe I wouldn't explain too much, but you're going to use JUnit tests. Okay, that's something you're going to use. And then you're going to implement some classes and methods that will actually implement certain data structure that we taught in the class. But I'll elaborate more as the assignments will be released. All right. All right. Let's say.
Hello, sir.
Yes, please.
Hi. Are we going to be using Eclipse and Java for this whole class, or are we going to learn other languages?
Yeah, it's a very good question. Yeah. So I think for your assignments and also for your programming test, okay, we're definitely going to use Java for sure. We cannot expect every CS student to know about Python actually, because some of you might have taken maybe 10, 12, in which case you only know about JavaScript, right? So in this course, just Java. That's why I said before, said in the beginning, if you feel not so confident about what you learned in Java programming from 2030, maybe you want to refer to my lecture site for 2030 in the last fall. Okay, but just have a chat with me if you have any doubts. Okay, and we are going to use Eclipse because for your assignments and programming tests, there is a particular format that will expect you to submit the project. For example, after you have completed all your programming tasks, you have to export your Java projects as a zip file. And the zip file itself should have really certain formats. So that's something I would suggest you definitely stick to Eclipse for this. But of course, if you really want to do some extra practices yourself, by all means, try other IDE if you wish. Okay?
Okay, thank you.
No problem. Okay, let's see. Okay. Okay, something about the JUnit tests, right? Okay, I will speak a little bit more as for when the actual assignments are released. But let me just say assignments and also for your programming test. Let me just talk about in principle. The details will be elaborated later. Assignments and also your programming test. Okay, so you will be graded by JUnits tests. For example, maybe in total there are maybe 50 test cases run to assess your code. If you pass maybe 35 of them, in that case, you will get 70% of the grade, right? Just calculate, okay? And now, all those 50 tests over here, some of them will be given to you, okay? There will be some starting tests, or I call starter tests, just to get you started, and also you will be able to have a very good idea about what you're supposed to really implement. And also there will be some extra tests. And these are the tests for us to really try to find out which student will deserve an A or A plus, or maybe B or B plus, something like that, right? But I would say if you can pass the starter test over here, you will receive at least, or roughly, I shouldn't say at least, roughly about 50%. Roughly, okay? It might vary between the assessment. All right?
Sir, I have another question.
Go ahead.
So I took 2030 with you last semester, and I think I really struggled with that extra test aspect. So
Right.
I wanted to ask, like, how would we think about extra tests?
Yeah, for the
edge cases and
yeah,
stuff
no
like
problem.
that.
I think I can definitely talk more, maybe during the Q&A, because it really depends on the specific assignments that you're supposed to do. So I would say, just say in general, what you're supposed to do is really to go over all the starter tests, make sure you pass them, and then try to think about, given the problem that's described in the PDF for your assignment instruction, and given all the comments that are actually set to you in the program, in the starter code, are there any missing scenarios from there, right? So I would say that's a principle. But I would say during the Q&A, feel free to ask me to really say you're struggling with coming up with maybe additional test cases. I can definitely give you some guidance, or just drop by my office hour. I think that might be more helpful to you. Yeah.
Okay, thank you.
Okay, awesome. Good. All right. Guys, in case I missed your question on the chat, feel free to retype it, right? Just in case. Okay, let me just go back. Okay. Actually, let me go back to the syllabus. Okay, calendar. All right. And okay, so guys, any question about the calendar? Hopefully that's clear. Okay. So you just have to know which days the tests are actually going to occur. Okay. And one thing that's actually important that I should say in the syllabus over here, right? Okay, so here, let's see. About the written test and also about the programming test. Okay, when they actually take place, they will take place. Let's talk about programming test number one. Sorry, written test number one. It will take place either during the class time on Monday, or it will take place during the class time on Tuesday. To be more precise, over here, you can see on the syllabus. So rather than having a 24 hours window, what I would like to have is like this. Okay, so the 30 minutes is going to be either during the class time of section N on Monday, or it will be during the class time for section Z on Tuesday. However, you can feel free to take either one of them. I hope that's clear. So let's say, for example, if you're from section N, you can feel free to actually take your written test number one over here. It will be Monday 14th or Tuesday 15th. Either you can take it on the Monday between 4 p.m. and 4:30, or you can take it between the 8:30 and 9. It's guaranteed one of them should really work for you because you sign up for the that particular section. So the class time should really work for you. All right. And the time constraint will be 90 minutes for a written test, and also 90 minutes for the programming test. I will speak more about the timing constraint as the individual tests come. All right. And similarly for programming tests, similar format. So it's going to be 90 minutes, and let's say your programming test number 1. So you can either choose to take it on the 28th of February, or you can choose to take it on the March 1st. In the case you choose to take it on the 28th of March, it's going to be from 4 p.m. to, sorry, it's going to be from 4 p.m. to 5:30, right? Sorry, there's a typo over here. I'll fix it. 4 to 5:30. And also, in the case of if you choose to take it on a Tuesday over here, it's going to be from 8:30 to 10. Okay, it's a 90 minutes test. Okay, guys, any confusion about how the timing for the test is going to be like? Any question? And for the assignments over here,
Professor.
Yes. Sorry, just give me one moment. Yeah, let me just talk about a quick question. Yeah, bear with me.
I
Just
have a question about the written test.
okay. Go ahead.
So we can take it on any day, right? Monday or Tuesday, it doesn't matter.
Doesn't matter, but it has to be, if you take it on Monday, it has to be between 4 and 4:30 for the written test, for example. If you take it on Tuesday, it must be between 8:30 and 9. That's the only constraint.
So our section doesn't matter, right? N or Z?
Section doesn't matter. Correct. Doesn't matter.
Okay. Thank you.
Good. Good. All right. And just about the assignments. So this block over here is just telling you that you're supposed to do the assignment in these 2 weeks. Typically, the assignment will be released on Friday. Typically, on the Friday before. Friday before. So, for example, I'm going to release assignment number 1 on this Friday. So you will have about 2 weeks to do it. Okay. Now for the due dates, I'll rather leave it to the specific assignment instructions to tell you exact due time for that. All right. The time constraint for the programming test is like 90 minutes. All right. So guys, let me say one more time for your test over here, right? Number 1, it is not the 24-hour test. It is not. Instead, you're going to take you're going to make an option. The option is up to you. Either for each test, you're going to choose either the Monday or Tuesday. In the case of Monday, let's say for a written test, it's going to be from 4 to 4:30. In the case of Tuesday, it's going to be from 8:30 to 9. And similarly for a programming test. But when I release the guide for each test, I'll make it clear again. So hopefully there was no confusion. All right. All right. I think that's everything I want to say about semester calendar here. Any doubts? Any questions, please? Anyone? Awesome. All right. Let me go back. Actually, let me move forward. Okay. So here's a Q&A session, which we have been waiting for long over here. All right, so let's now talk about, so this will be your schedule. You can think about this is the schedule for both section N and section Z, okay? Originally, this is the time for on Monday for section N to have a lecture, right? That one has been turned into only have a test when it is scheduled, right? So for example, if we are now in the week for the written test, you can either take it here or you can take it here, right? This is the time for section N. This is the time for section Z, but it doesn't matter. You can go to either this or this. That's about the test, right? But it does not occur every week, right? You can look at the calendar over here to see which week actually we got a test over here, right? We got 4 tests in total throughout the semester, only 4. Well, I shouldn't say only, but we got 4. All right, that's about the test. And then let's talk about the Q&A over here. So the schedule, the class time for section N and the class time for section Z, right? So there will be 2 things I would like to do, okay? And number 1 is similar to what I did in my 2030, if you took it with me, is going to answer for sure lectures questions, okay? And number 2 is what I want to add this time just to maybe motivate more of you to actually come to the Q&A if you want to. Again, Q&A are optional. We don't take attendance in the Q&A, right? So it will be to your benefits. And number 2 will be, I'm going to bring some problems for us to solve. Since I mentioned before, this course may be treated more like an interview training course. So I think it might be good for me to give you some extra examples. So what I would like to do is maybe for each section, I'll bring maybe 1 or 2, not that many. For each question there, I'm going to bring present to you what the problem is, and I'll give you some time to sketch your solution, and then we can have some discussion, and I'll give you at least a complete sketch of the solution. All right, so that'll be the purpose for the Q&A over here and over here. Okay, so you can feel free to join one section here, or you can join both if you wish. It's completely up to you. Are the exams online? At the moment, I would say it will be online, unless on the January the 31st, we decided to go back in person, in which case we may take the exam in person. At the moment, I would say it will be online at the moment. All right. Guys, any question about the weekly schedule over here? Okay, just notice that starting from next week, for Monday and Tuesday, just watch out for any of the Monday and Tuesday where we got a written test or the programming test, number one. Number two, for your Wednesday and Thursday section over here, you can feel free to join for Q&A to ask about the lectures, or maybe we can go over some interview type problems together. Hopefully that will help you as well beyond the course. I cannot do too many in the Q&A. I'll try to find some problem that may not be so challenging. Well, maybe sometimes challenging one, but we'll see. Okay, but anyway, hopefully that at least to motivate you to really go beyond what I teach in this course, to really give yourself a little bit more extra study, right? We'll definitely talk more during the Q&A, starting from next Wednesday. All right. Okay, let's see. Good. Okay, another good question here. Let's say over here, you can see here, the Monday and Tuesday, you only got something to do when there are some tests, okay? And you can see here, what about the Monday? Okay, of course, not this week. This week, you're already here. For example, week number 2, 3, 4, 5, over here, nothing to do. You don't need to do anything. Nothing, right? For the Mondays and Tuesday where there are no tests, you simply don't need to do anything, all right? Good. All right, that's about the... Okay, so this part here is just about the tentative topics for the lecture. I'm recording all the lectures from scratch, so I'll try to make sure I meet the deadline to really make sure I release the lectures on Wednesday for you. I'll make sure I do that. So the order of the topics over here may be subject to changes, but you don't need to worry. I'll definitely make sure you got enough to study for every week. And luckily, I already got your videos available for week number 1. Well, I'm still processing them, so it will take me a little bit of time to process the video, but I'll make sure it's released on Wednesday, no later than that. Okay. All right, that's about syllabus. Guys, any questions about the syllabus anymore? Anyone? All right, seeing none, hearing none.
Sir, I have a question about syllabus.
Sure, please go ahead.
Is there any particular topic that's like the main focus for this course? Just like
Okay.
inheritance was for EECS2030?
Okay.
Something that we should be looking forward to?
Yeah, sure, good question. Good question. The question was, is there a particular big topic that we're going to focus on for this week? You know, in some way, you're right. In 2030, well, if you took it with me, of course, maybe different from other instructors. For me, I definitely emphasize a lot about inheritance and also, you know, about the more advanced feature for OO. I think for this course, I think there will be quite a good number of, you know, big topics. I can tell you what they are, but we're going to learn them one by one. Linked lists is a very, very big topic over here. Even though we only covered them for 2 weeks, but I think linked lists you want to make sure you pay extra attention to. It's definitely it always appear in every programming interview that I heard about. Linked lists for sure, but we'll get there. Okay, and also I think hash table is an important topic, and also we're going to revisit recursion. We already learned about some basics about recursion, so I may not repeat all the basics, but we're going to see a little bit more advanced example about recursion. Especially we're going to see about some advanced sorting algorithm, which we'll get to. Don't worry. Okay, and then the trees will be a very big topic, which we're going to spend about 3 weeks after the reading week on, and also graphs as well, which we'll also spend about 3 weeks. So I would say there's not really a particular very big topic, but I think the theme will be we want to learn individual data structures, and there each one of them I just mentioned, they are one kind of data structure, so many things that we're going to focus on. I hope that answered your question.
Thank you, sir.
Good. Thank you. All right. Okay, so let's see this. Oh, by the way, did I ever mention my email? Maybe I haven't, right? If that's the case, that's my bad. Let me show you my email over here. Yeah, it's here. If you want to email me, just email that. So Jackie@eecs.yoku.ca. That's my email. All right. Just my departmental email. All right. If you want to email me, that's the address. Okay. All right. Let's now move back to the slides. I think we have done with the syllabus. And for those of you who actually got some official accommodation request, so please, I'll be happy to set it up for, with you. Please get in touch with me. Okay. All right. And then I think we are now it's about 4:55. I want to spend about the next 15 to 20 minutes just to give you a little bit more insight into why we want to take this course. Yeah. But before that, is there any administrative question you want to ask me before I dive a little bit more into something specific to the content for the course? Anybody? Anyone? I'll pause for one more moment in case you got questions. Please feel free. Okay. All right. I think starting from now, I will spend hopefully the next 20 to 30 minutes, hopefully just 20. I want to just give you a little bit more tips about how you're supposed to study this course. And also, I want to give you some motivating examples about what you will be able to solve after you finish this course. Okay. All right. So what I said before is you can think about this course is more like a training you for the future programming interviews, right? If you want to become a software engineer, I guess maybe one of you maybe are thinking about that particular job, which is promising, of course. And how a real software developer works, which I also mentioned in my second year course or even first year. So very quickly, you want to be able to program your solution according to a certain API. And the API is simply going to be input and outputs, like a method declaration, right? So maybe given some JUnit test, you want to infer about what the test method should be declared. For those of you who took 2030 with me, we did lots of exercises on that. And also you want to make sure you follow the test-driven developments methodology. So you want to make sure you use the set of JUnit test cases to tell you how correct your code is, right? That's something you want to always keep in mind, all right? And you want to think abstractly. So that's something we'll definitely do also in this course. So whenever I talk about a particular data structure, I'll try to show you some Java code, but I will also try to give you more visualization and also more insights into why we're doing things in this way or not in this way, so that you can be creative about making new things yourself. That's why I'm doing this, okay? So one complaint I got, which I will happily take it, is student complain that my lectures might be too long. I agree, but that's because I really want to make sure I am thorough in terms of the explanation. So anyway, there's always a catch. So we'll see. And there's some example over here. So for those, you might actually simply have to have a programming interview in some company. You can definitely take a look at this link. This is just some example about how the interview can take place. In which case, you may not necessarily got an Eclipse besides you to actually program. You might be just given a problem informally by somebody from your company, and then you are supposed to program your solution on the whiteboard. In that case, you want to make sure you actually program your solution in a way. Number one, it will compile mostly. And then number two, it should really be able to be as correct as possible. That's basically what you're expected to do in the programming interview. But that's something we'll try to do during the Q&A as well to practice together. All right. Okay, so here, take advantage of the Q&A sections. I'll bring problems. I understand that when we run things online, unavoidably, attendance for Q&A, especially as optional, might be incredibly low. But I'll do my best to really bring some useful stuff to the Q&A so that you can actually take advantage of. I can tell you that even though the Q&A session will be recorded, but I can tell you that it's not so feasible to expect yourself to always watch the Q&A after it's been released for its recording. Why don't you just join the live session and participate in the discussion? That would be my suggestion. Okay, study tips. And then make sure you study the lecture videos and also come to the Q&A. All right. Ask questions. One more thing about the tips. I think up to now, you guys actually have studied quite a good number of CS courses or engineering courses. I think that's always I tell my student, it's a very unpleasant fact. To do well, inspiration is definitely more important than perspiration, meaning that working hard is actually very, very important. However, working hard or completing the task doesn't really mean you get a good results. That's very something that we have to take. Okay, but what will be the best you can do? You want to make sure you do the hard work, and then always think about the how things are connected. Right? So we're going to study lots of data structure throughout the course. Always think about why things are done in this way. Try to train yourself. And whenever I give you a particular example to play with, also take the opportunity to really do the example yourself and try to change something to see what's going to happen as a consequence, etc. And I think at this point, you may want to consider maybe looking into a website like a LeetCode. I think people got lots of programming exercises over there. Myself, I actually subscribe to LeetCode, so I'll try to bring some example problems from there to the Q&A just to share with you. All right, maybe some, not all of them. And Coding Bat is actually what I recommended back in 2030 and 1022, but it might be too advanced for Coding Bat already. So I would suggest maybe LeetCode or similar website. Okay, you can consider. All right. Let's now talk about what this course is about. I'll try to use within 20 minutes to give you some motivation about why studying hard for this course is going to be worthwhile. Okay, given the kind of problems you will be able to have a good sense about how to solve them upon graduation from this course. We're going to talk about data structure, of course. Especially, we're going to talk about different ways of organizing and accessing data, right? So there will be many ways. Well, up to now, the only data structure you have learned up to 2030 is arrays. Of course, you might talk about array list or maybe maybe factor that you can use from the API in the Java, but those are not the things you develop by yourself. So I'm talking about the only thing you have learned about how to develop by yourself from scratch is primitive array, right? Remember a primitive array? This notation over here, right? Primitive array, for example, integer array. So that's only one way to really organize the data or to make changes by using the indexing notation. When you say A at index I is assigned to 2, for example, that's the only thing you have learned. But in this course, we're going to challenge you about using different ways to store the data and to really change the data. That's something we'll get into, different data structure. And so these are just some examples. We're going to revisit arrays to give you some more new insights. We're going to learn about linked lists. It's a very important topic, as I mentioned earlier. We're going to learn about stacks, queues, and also maps, basically hash table, and also trees and also graphs. So these are things that we are going to touch upon in this course. We're going to learn about algorithm. So algorithm is very closely related to your data structure. You can think about algorithm is a Java program you write, and data structure is the data type you actually use, like array. That's one analogy over here. And we can learn about inserting, deleting, and also sorting, and also searching. For example, sorting over here. Every CS or engineering or software engineering graduates should know at least, maybe at least around 5 different ways to sort a sequence. I didn't really teach any sorting actually in 2030, but in this course, we're going to learn about something called selection sort and insertion sort in the second week, and learn about merge sort and quick sort later, and also heap sort. So at least you will learn about 5 different sorting algorithms in this course. And of course, not just about learning them, but also to learn about the rationale behind how they work and also how fast or how efficiently they can work. That's also very important things for you to learn. Also about searching. Given a big database, how are you supposed to search in the database? If you only got an array, if you want to search some element from there, we know pretty well just write a for loop. But we have to consider efficiency as well. That's something I will elaborate a little bit further. Okay, we're also going to do analysis, which will be the focus for the first week. So for the first week, you're going to learn about the time efficiency for the algorithm. Especially, we're going to review some mathematical foundation. And for those of you who took 1019, I'm pretty sure every one of you did, you actually learned about a big O notation called the asymptotic analysis. So for the first week, I'm going to assume everybody have learned that already. However, I'm going to review all the important concepts together with you about the asymptotic analysis. That's something we'll do for the first week. And then we'll move on to the more to the data structure and algorithm starting from the second week. All right, that'll be the plan. Okay, guys, I think now it might be good to for us to have some idea about, let's think in perspective. At this point, you don't really know how to solve any of the problems I'm going to give to you. However, hopefully after complete the course, you will have a much better foundation and idea to solve them. Let's talk about each one of them. I got about 4 or 5 different problems to go over quickly. Okay, let's talk about the first one. How would you save the records in a mega city with 10 million residents? So when we say mega city, there should be at least 10 million residents. Let's say exactly 10 million. And given a particular resident's social insurance number ID, let's say everybody's record can be identified uniquely by just the ID, like an integer. How fast can you locate their record? Okay, I think, yeah, guys, you want to think, throw ideas to me. I can see hash map. Well, sure, but hash map is definitely something that we're going to talk about when we get to the hash table lecture. Of course, for hash map, you have to watch out for like a collision problem, which I'll discuss later. Okay. Binary search, very good. Binary search will be something that we definitely will talk about in detail. But in order for you to do binary search, you have to do the preparation work to make sure the thing for you to search on can be performed binary search. You cannot just perform binary search on any arbitrary data structure. It has to be a particular data structure. Okay, next for discussion. Okay, I want every one of you, I'm going to switch to my notes over here. I want everybody to consider this particular algorithm. It's a fragment of code over here. Right, you can see we got a find method over here. Given some social insurance number, which is an integer, we're going to return the corresponding resident record over here. Okay, and intuitively, we're going to run a loop to go from the beginning until the end. Right, and then if the current record we're looking at, its SIN number is simply equal to the input, we're going to return that particular entry. That means we have found it. Maybe otherwise we should return null, but that's okay. Now here is the question. Is this, well, this most likely will be how you will write it maybe in your 1022 or 2030, most likely. Let's say if you're forbidden to use the library data structure, right? That's most likely what you will write. But is this an efficient algorithm? Especially we're talking about 10 million records. Okay, since I'm asking you this way, it must be no, right? Okay, I saw depends. What do you mean depends? Umia, you want to speak up? What do you mean depends? You are saying that this algorithm could be efficient at some in some scenario?
No, I'm not really sure actually.
Okay, that's okay. That's fine. Okay, well, let's talk about a little bit more. Okay, I just want to give you some idea. We'll definitely elaborate throughout the course. Let's say this is our database, DB, right? And we're talking about an array for the mega city residents. So that will be 0, 1, all the way to, we said 10 million, right? 10 million minus 1. That will be the largest index. Let's say that's the array we're using. Okay. And now I want to talk specifically about two notions. One is about best case. The other one is about worst case. Let's think logically. And I want you to quantify best case and also worst case in terms of the number of iterations that will take us to return. All right, number of iterations over here. And here's a question. What would be the best case? 1 iteration. Well, that's obvious, right? So if you say the best case is simply just one iteration, that means we have found it right away. We're lucky. However, lesson number 1, which I also emphasized in week 1's lecture, whenever you want to claim the performance of your algorithm, don't bother with best case, because best case could be much worse than the worst case. So best case is only for your reference, but don't rely too much on that. What about the worst case? Well, apparently, worst case would be either the resident you're looking for maybe happen to be at the last element in the array, or they simply don't exist. In that case, you have to go over all the 10 million resident records and then exit the loop without returning, just returning null, right? So that'll be 10 million. All right, I want to have everybody's agreement quickly. It's very straightforward. I just want to draw some connection from what you learned before in 2030 and to here. Right? The worst case is pretty bad. We need 10 million iterations in the worst case to really find out who this citizen is. What we're going to learn in this course is, let me give you a little bit look ahead, but that's going to happen after the reading week. We're going to build certain data structure called balanced. It's called balanced binary search tree. Okay, don't worry too much about it. I just want to mention that. Somehow the balanced binary search tree can look something like this, and then we're gonna store all the 10 millions records into the tree. And the mathematical property of balanced binary search tree tells us the height of the tree is going to be log of the 10 million, which is roughly about 23. Okay, roughly. And every time you want to look for a particular number, you're going to do something like this. You either go to the left or to the right. Oh, let me say it again. You go to the left, go to the right, go to the left, go to the right. So the worst case, you're going to traverse all the way to the bottom of the tree. And the height of the tree is guaranteed to be up to 23. So we are talking about the worst case will be 23 iterations versus 10 million. That's kind of the drastic improvement you're going to learn about how to make after the reading week. All right, guys, it's a very classic computer science problem about searching, right? So whenever you want to do search, you don't want to do it this way. It is a so-called linear time search, which you will learn in the first 2 weeks. And this over here is called the logarithmic search. So you're going to learn about is so-called the big O of log n, where n is correspond to the size of the array, right? Don't worry, don't stress over too much if you don't follow the detail. That's the precise detail will be supplied once we get there. All right, that's the first problem I want to talk about, searching. Right. All right, so that's the first one, and I'm going to talk about the other ones quickly. And the second one, I just want to give you some visualization. Let's say if you work for the maybe some travel agency company, right? So you simply want to plan out some itinerary of maybe some trip. Maybe the trip will actually go, let's say I want to fly from Toronto to, let's say, Beijing, for example, right? There may be a direct flight, or maybe I can say I can fly from Toronto first to Chicago, and then Chicago to New York, and then from New York, direct flight to Beijing, right? So there might be different routes for me to choose, depending on what my concern is. If my concern is about the ticket's price, in that case, making some transit might be cheaper. Of course, direct flight will be the most expensive, right? So we're going to learn about not exactly this example here, but potentially the application you can build is by encoding all the cities that will be covered by the airline company, and then try to see what will be the best route to go from. For example, let's say here is Vancouver all the way to Toronto. That might be the best way, right? That's just about building a graph. It is a graph data structure that we're going to learn later. Okay, I wouldn't say too much about graph. It's I really need to show you the precise details before we can talk. But that's just a high level example about routing the itinerary. Another example would be if you drive, for example, this might be something you use very often. Let's say I want to go from York Keele campus to Glendon campus. So let's say depending on the driving condition at the moment, depending on the traffic condition, if you try the Google map, you simply go from Keele to maybe Glendon. They will tell you these are the alternative 3 different routes. one will take about 27 minutes and 27, and the other one will take about 28. So they give you different path to really reach your destination. How do you really find a path to go from one, we call it node on the map, to the other nodes on this? So there will be some algorithm about graph searching that we have to learn later. So this will be the ending part for the course, about the final 3 or 4 weeks. Okay, so that's about the routing problem. And the final one is really something I find very, very exciting about making use of the tree data structure. Okay, let me give you some idea. And by the way, the 2 problems I'm talking about right now, we are not really going to solve them per se in this course. It will be too difficult for every one of you. We don't want to do that. However, for those of you who are really much into the kind of a program optimization or program translation problem, so there is a course called EECS2011. It's called the Compilers and Interpreters. Okay, it is a course to actually show to you how you can design your own programming language and go for translation from one to another, right? But let me give you some idea over here. Okay, what I want to show you is the kind of stuff you can do. Let me just show you some visualization over here. Take a look at this code over here. It's not really Java, but it's kind of intuitive enough. Let me just tell you what's happening here. Let's say we declare we have B. We have 3 variables: B, C, and also A. B is assigned to something here. They're initialized. And we are trying to run the loop. Okay, the loop is going to go from value of I, lower bound, until and including the upper bound n. So we're going to run n minus I plus 1 iterations. And the loop counter is going to be called I. All right, so far so good. For every iteration, we are actually going to read an input value D. And then we're going to reassign A to B this particular expression. Okay, that's the code. All right, let me give you a little bit of time to think about, is there any potential way to improve the performance of this particular loop? If you stare at this code over here, feel free to say anything. Don't be afraid to be wrong. That's okay. If anyone want to share anything, go ahead. Otherwise, I can tell you what the answer might be. Is there any way for us to improve the performance over here? Anyone? D is unchanged. Actually, no, because D, in some way, D will be reading something from the user, so it will be changed from every iteration. So it will be changed. So D cannot be moved. Yeah, go ahead.
Can we multiply A by itself and 2 and B and C before the outside the loop?
Correct. Can you say that again, please?
Okay, so D is changing, but B and C are still the same. So
okay,
can we multiply that outside the loop?
Yeah, good. That's pretty much on the right track. Very good. Okay, but guys, don't feel bad if you don't spot that. But that's very good. Very good. Awesome. Brilliant. This expression here is pretty stable. Meaning that once B, C are assigned to their initial value, they never got changed in the loop. So 2 multiplied by B multiplied by C doesn't need to be re-evaluated for every iteration. What we can do is we can factor this one out outside the loop. Just evaluate this expression over here only once, and then reuse it for every subsequent iteration. So that'll be the optimization technique. However, you guys are pretty intelligent, so you can spot this very quickly. How can we expect a computer to actually do this? That's the question, right? In this case, we need some technique called compilation. I'm pretty sure you heard about this term before, right? So at a higher level, we want to transform this particular program into an optimized program that goes like this. This is the optimized version, which exactly what your colleague just said. Over here, you can see we try to do evaluate 2 times B times C, which is stable, and then we try to apply. We try to multiply that. Sorry, there's a little typo over here. I'm going to fix it. Sorry. Let me get rid of it. I think what I meant to say over here is A times D multiplied by the temp. Okay. So what we're doing is we're evaluating this particular expression that is stable outside the loop only once. And then we're going to use the value of temp for every iteration. So that can save us for many re-evaluation. So that's an optimization problem. Okay. Let me now move a little bit more into how exactly that will be done. Okay. For those of you who might be taking or who might have taken EECS 2001. Okay. You learn about something called context-free grammar. Right? Hopefully that sounds familiar to you. All right. Basically, every programming language should have its associated context-free grammar. Given the context-free grammar and given an example program, you are able to give its corresponding so-called parse tree. Or sometimes people like to call abstract syntax tree. Let's just have some idea over here. For example, if you look at this two part over here, sorry, I want you to look at this one here, and this one over here. At the top level, we have a program. And the program got several children over here. We got an assignments, and this particular so-called subtree correspond to B is assigned to this. That's why you see B is assigned to something over here, right? And this subtree over here correspond to this particular assignments. And this particular big subtree over here correspond to the loop that's over here. So this tree is so-called a tree representation of the original program. And why is this useful? This will be useful because now if we want to do any analysis or so-called transformation on the tree, we can manipulate directly on the tree rather than manipulate on the string of the original program. That's insight number one. Insight number two, you will learn about how to build such tree after the reading week, right? May not be exactly this application, but you'll learn about different ways for you to really traverse the tree. But guys, to really give you some facts, in order to really be able to implement transformation on trees very well, you have to be very, very proficient in recursion. Every time you talk about doing something on the tree, maybe go from one tree to another, in that case, you have to do it recursively. That'll be the most efficient way, or maybe the most convenient way for you to actually specify the algorithm. Okay, so I'm going to review the recursion before the reading week, but we're also going to use recursion a lot when we talk about trees and graphs. So once you got an abstract syntax tree for this particular source program, you can perform recursion somehow, transform it to another tree over here. And this tree can be somehow, you can think about the toString method that we're implementing, can be pre-printed into this particular target program that's optimized. All right, that's kind of the idea. And it's a very cool application about using the tree data structure, applying recursion, and also using the compiler technology. But it's going to be not going to be done in this course. But for those of you who might be very interested in this kind of idea, consider 4302 later. Okay. Anyway, one more example to show to you, and then we are done. One more. Okay, another one, similar idea. So now rather than just optimizing your program, you want to maybe do some translation. In theory, as long as you can define the context-free grammar for certain programming language, you will be able to translate it into another one, as long as you can really do the proper tree operations. Okay, let's talk about this one specifically. Given some user-written object-oriented programming programs like a Java, you want to translate it into something completely different but equivalent. Because I want to store all my objects and methods into relational databases like a SQL. How can we do that? Right? This is also a very typical problem you may have to solve when you do the job. So the idea will be very similar to this, very similar diagram. I'll just show you the idea quickly. Okay, you can think about this part over here is the this part here is the object-oriented program. You can see we got class, we got attributes, We got some data type, and also we got methods over here. The syntax is not exactly Java, but similar. Okay, so this is source program. Eventually, we want to translate them into SQL queries. Okay, you can see here we got a table for the account class, we got a table for a traveler, and etc. Okay, the precise detail is not important. Basically, we want to translate from one language to another. We cannot do it directly. What we can do is we try to parse the source program into some abstract syntax tree, similar to what we saw earlier. So let's not worry about the detail. Once you got an abstract syntax tree for the source object-oriented program, you can transform the tree into another tree. And that tree over there can be pre-printed into the final SQL programs. Okay, that's kind of the idea. And that's hopefully so far the problems here, just to give you some idea about what you will be able to start doing after completing this course, just to give you some motivation. All right. All right, I think that's about it. For those of you who might be interested in looking at the details for this example, I'll make the enlarged version, the zoom in version for the diagram on the lecture site later, so you can take a look if you're interested. All right, guys, that's about it for what I want to say. Do you guys have any other question before I let you go? Please. Yeah, one final thing I'd like to encourage you. Starting from next Wednesday and Thursday, we're going to have the Q&A. Okay, it's optional, so I cannot really force you to come. But I really encourage you to really drop by if you got any doubts about the lectures, and also maybe have some discussion together about the programming problems or maybe interview problems I'm going to bring. Okay. If you guys have no more questions, in that case, I will let you go. All right, guys, take care, stay safe, stay healthy. And then please check your email every day, and then I will be in touch if there's anything important you should know. But you can expect the lectures to be available to you on Wednesday. All right? Before that, relax and then catch up with OOP if you want. And I got office hour tomorrow. All right? All right, guys, you take care. Bye-bye. Take care.